Assalamu alaikum. Today I will talk what is a total derivative. You see word by word total derivative. You will know what's total derivative actually. Total means sum, derivative means change. So we want to know total changes, right? So total changes in where? By the way, so we know we can take derivative only on function. Actually, we are looking for total change in function or in a system. So we have function u, and u is a function of x1, x2, x3, and so on, xn variables. So we have n variables, and physics term or chemistry term we say like we have n parameters. So we want to know influence of these parameters x1, x2, x3, xn on function. So total change du is a total change, and total change is equal to sum of all changes. So summation I01 to n partial u or partial xi. We can say w or w xi dxi. You see w or w x1 and w over w x2 and w over w x3 and so on w over w xn. W over w x1 means slope at x1 axis, and w over w x2 slope at x2 axis. And how many slopes we have? N slopes. So we open this summation sign. See, total derivative is equal to w over w x1 dx1 plus w over w x2 dx2 plus and so on w over w xn dxn. So we have how many slopes? 1, 2, and so on, xn derivative. So this slope means like we are looking changes. So we have n parameters changes. So and then if all together is equal to total derivative in total change. So geometrical interpretations, it's geometrical interpretations like in case of a function of two variables, z is a function and function of x and y. So it's a total derivative is equal to dou f over dou x dx, dou f over dou y dy. Similarly here. So you see we have a graph. We see this graph, three axes here, x, y, and z, and z is a function of x and y, and we want to know total change in z. This is like height dz. So here you see two graphs, two curves at this point P. APB, this is first curve, another curve is C at this point P, CPD. Okay, so first slope to the curve APB, and this curve to the curve CPD, and C common intersection point is here is P. So dou f or dou x is slope at this axis, dou f or dou y, this is slope at y axis. So this curve shows and this tangent line shows dou f or dou x. See here, and this curve CPD, and see this curve slope line shows dou f or dou y. So a total change is here dz. So actually we want to optimize maximum profit or minimum cost. Actually in optimization technique, like this is optimization technique, or in the subject optimization technique subject or operation research. So we can interpret in different uh, situations, like so you are cooking and you want to know how many, you want to know we are adding these spices and then become good delicious food. You want to know actually how much a spice used, how much this spice used, that spice used. So like uh, most of in Pakistan and Indian guys used to cook kadhai while staying in abroad. So they use haldi masala, turmeric masala, spice, uh, lal mirch masala, red pepper, spice, and mix masala, like a mixed spice, or different spices they use. So so we want to know how much I use turmeric powder, how much I use red pepper powder, means concentrations, right? So we want to fix their concentrations, so and then our food become delicious. So we can apply to that in economics. So it's like z is a function of x and y, right? So z is a function of demand and supply. So we want to know price. Suppose I'm launching a product, so I want to know its price. I want to select price. So where we can select price in equilibrium point. So here see P is like this point slope, it become equilibrium. So in concavity, actually we do in concavity first we take a derivative function and then we equate it with zero. Why we equate with zero? Because because at this point P, either maximum or minimum we don't know, but we know it is point at maximum point or minimum point. This is a maximum point, this is a minimum point. So at these 2 points, at this point P, which is either maxima or minima, so slope should be equal to 0. So that's why we equate 0. So after that we don't know. We know at this point we no, there is a maximum and minimum point at the function. So if we know like we will get like maximum point or minimum point, but we don't know either maximum or minimum at this point. So at this point P, or at particular point. So I represent P. Okay. So here's P, the intersection of two curves. Okay. So we see second derivative. First derivative is like this is a curve, and this is a tangent line. Okay, this slope, and this is first derivative dou f over dou x. Suppose actually in x-axis, sorry, x-axis here, right? This is x-axis dou f over dou x. So we want to take a double derivative dou 2f over dou x2 is like it's like normal line. So if we see normal lines like normal line is downward, means that is negative, or slope is negative. Second derivative is negative, means your this point is maximum point. So if secondary is positive, is like secondary is positive, means this point P is minimum point. So actually through derivative we also know maximum points, and we also see if we how much amount we change, and we can get maximum or minimum profit, or what you want. And suppose you want maximum profit, you want minimum cost, and you want suppose I use this amount of spices. So it has a lot of applications. Just I have given some some examples. But anyway, so we will solve a problem of total data in next video. Hope so.